Hello everyone. In this lesson we begin with chapter 2, finding limits. Listen, I skip lesson 2.1 because it is not important. We start with lesson 2, finding limits graphically and numerically. But before we start with this lesson, I'll solve two questions from Are You Ready? From the page of from questions of Are You Ready? Question number 5 and number 6. Number 5, is the inverse relation of y equal 4x plus 3 a function? If we want to know it is a function or not, we will rewrite it as x a function of y. It will be 4x equal to y minus 3, then x equal f of y equal 1 over 4y minus 1 over 3 over 4. As you see, this relation is a function because for every value of y there is exactly one value for x, then the condition of function satisfied on this relation. Number 6 is the inverse relation of y equal x power 2 is a function. If we rewrite it as x a function of y, it will be x equal negative positive square root y. This relation is not function because for every value of y there is two value of x, and this is introduction. Then this relation is not function. For example, if we give a y value 4, then x equal negative positive 2, negative 2 and positive 2. Finding limits numerically, calculate the values of f of x equal x over square root x plus 4 minus 2 when x approach 0 or when the value nearby 0. As you see, when x equals 0, the function is not defined because 0 over 0 plus 4, 4 square root 4, 2 minus 2, 0 over 0 is undefined. Then the function is undefined as 0, but we want to know the behavior of this function when x approach to 0. Then we will take several values after 0 and several values before 0 and find the value of f of x. When x equals 0.001, f of x is 4.0002. When x equals 0.01, the value is 4.002. As you see, f of x is approach to 4 when x approach to 0 from right. From left, when x approach to 0, the f of x is 3.97, 3.997, 3.9997. Also, f of x approach to 4. Then f of x approach to 4 when as x approach to 0. This is how to find limits numerically. I take several values after 0 and several values before 0 and see the behavior of the function. If the function approach from the same number from left and right, then there is a limit. If the number different, then the function has no limits as x approach to 0. Definition. one side limit. The right side limit is limit x approach to c from the right for f of x equal a. What does that mean? It is mean f of x approach to a as x approach to c from right. As you know, every number in the number line has left and right. This is c. If we suppose that this is c, then x is here approach to c from the right, and if x is here and approach to c, then it is approach from left. This is from right and this is from left. The left side limit is, we write it as limit x approach to c from left. This negative in the top of c is mean it is mean that x approach to c from left, and this positive in the top of c, it is means that x approach to c from right. This equation means that f of x approach to b as x approach to c from left. Example, how to find limits graphically. Use this graph to answer these three questions. Find the limit of f of x when x approach to -1 from the right. This is -1. This is -1. From the right, this is the right. When x approach to -1 from right, as you see, f of x approach to 0, then the right choice is D. Limit f of x when x approach to -1. When we write, the question, in the question written x approach to -1 without left and right, it means from left and right. If the limit from left equal to the limit from right, then the limit exists. If it is not equal, then the limit does not exist. Let us see the limit from to f of x from left and right. In the previous question, we see that the limit when x approach to -1 from right is 0. But as you see, when x approach to -1 from left, f of x approach to 2, then the limit does not exist. Answer D. Which is true? Question number 3. Limit x approach to 0 for f of x equal to 0. Let me see. Limit x approach to 0. This is 0 from left, from right. This is 0 from left. As you see, the function approach to 1 from both sides. Then this is wrong. Limit f of x equal to when x approach to -1 from left. -1, this is -1. From left, yes, it is true. This statement is true. When x approach to -1 from the left, f of x approach to t as to 2 as you see. F of -1 equal 2, it is wrong because f of -1 is 0. None also is wrong. The right choice is B. Another example, use the given graph to find f of 6. F of 6, as you see, it is a gap. When x equals 6, it is a gap and the function is not defined at 6. Limit f of x when x approach to 4, we will analyze the limit from left and from right. As you see, when x approach to 4 from right, f of x approach to 3, and when x approach to 4 from left, also f of x approach to 3, then the right choice is 3. Limit for f of x when x approach to 1 from right. When x approach to 1 from right, the function approach 0. Then the right choice is A. Limit of piecewise function. If f of x equal for piecewise function, we will find the limit from left and from the right. If the answer is equal, then the limit exists. If the answer is not equal, then the limit does not exist. Let us see this example. F of x equal 1 when x not equal to 2, equals 0 when x equal to 2. Find limit of f of x when x approach to 2 from left. When x approach to 2, it means x not equal to 2, then the limit is 1. From left and from right is also 1. Example, f of x equal piecewise function, as you see, find limit x approach to 0 for f of x. I'll find from left and from right and see the result. When x greater than 0, from the right, 0 minus 1, it is negative 1. Then limit when x approach to 0 from the right, I substitute in this segment x minus 1, it is negative 0. Minus 1 equal negative 1. When x approach to 0 from left, I'll substitute in this segment negative x plus 1. Since x less than 0, then the answer is 1. Negative 0, 0, plus 1 equal 1. Since 1 not equal to 1, the limit does not exist. Example, f is a piecewise function defined as you see. Find the limit of f of x when x approach to 4 from left. From left, it means when x less than 4. X less than 4, it is this segment. Then I substitute here limit x approach to 4 from left for 8 minus 2x equal to 8 minus 2 times 4 equal to 0. The right choice is A. If I want to find, I found already the first one, it is 0. If I want to find the limit for f of x when x approach to 4 from the right, it means when x greater than 4, and the answer is 4. If I want to find limit when x approach to 2 from left, it means when x less than 2, then 2 times 2 is 4. If I want to find limit when x approach to 2 from right, it means x greater than 2. I substitute 2 here in this segment. 8 minus 2 times 2, 8 minus 4, it is 4. Example, f of x defined as a piecewise function. Find the limit of this function when x approach to 2 from left. X approach to 2 from left belong to this interval since it is greater than 1. Then I substitute 2 in this segment. Limit x approach to 2 from left for 2 minus x equal to 2 minus 2 equal 0. Also, if I want to find the limit when x approach to 2 from right, also I substitute here because 2 greater than 1 and it is belongs to this interval. Then 2 minus 2, 2 minus x equal to 2 minus 2 equal 0. Since from right and from left is the same number, then the limit in general when x approach to 2 is 0. Show that limit when x approach to 0 for this function, absolute value x over x does not exist. When I have absolute value term in a function, I rewrite the function without absolute value. As you know, absolute value x equal to x when x greater than or equal 0, negative x when x less than 0. If I rewrite this function, then absolute value x over x equal to when x greater than or equal 0, I substitute absolute value x with x. Then it is x over x. When x less than 0, the function will be negative x over x. I substitute absolute value x with negative x. Now, x with x, it is 1 when x greater than or equal 0. X with x, it is negative 1 when x less than 0. If I want to find limit when x approach 0 from right for f of x, then from right it is mean when x greater than or equal 0, the answer is 1. And limit when x approach to 0 from left, it means when x less than 0 and the answer is negative 1. Since negative 1 not equal to 1, the limit does not exist for this function when x approach to 0. Unlimited behavior. Definition. If the value of f of x increases without bound as x approach to a number to c from left and right, then the limit of this function does not exist. This case often happens when we have a number divided by 0. If the number is positive, then the function goes to infinity. If the number is negative, negative number divided by 0, then the behavior of this function goes to negative infinity. Let us see these two examples. Limit when find the limit when x approach to 1 to the function 1 over x minus 1 power 2. If I substitute every x with 1, then 1 minus 1 equals 0, then the answer is 1 over 0. 1 over 0, it is infinity or does not exist. Does not exist. And the graph of this function is when x equal 1, we have a vertical asymptote, and we have a function goes to infinity as x approach to 1. Another example, find the limit when x approach to 1 for negative 1 over x minus 1 power 2. If I substitute every x with 1, then 1 minus 1 power 2 equal to negative 1 over 0. Negative 1 over 0, it is undefined, then the limit does not exist also, but the graph it will be also I have a vertical asymptote at 1 and the function goes to negative infinity. Another headline in this lesson: oscillating behavior. The value of f of x are oscillating between two fixed value as x approach to c, then the limit does not exist for this function. If the value of f of x oscillating between two fixed number, then the limit does not exist. Discuss the existence of the limit cosine 1 over x when x approach to 0. If we want to find this value numerically, when x equal to pi, 1 over pi, 1 over 2 pi, 1 over 3 pi, 1 over 4 pi, and so on, we will see cosine 1 over 1 over pi cosine pi, it is negative 1. As you know, the graph of the cosine is like this. This is pi, and this is negative 1. This is 1 pi, and this is 2 pi here. So, cosine 1 over 1 over pi, it is negative 1. Cosine 1 over 1 over 2 pi, it is 1. Cosine 1 over 3 pi, it is negative 1. Here over 4 pi, it's 1. As you see, if we take equal step size value for x, I'll get the value of f of x. It's oscillating between two fixed number, negative 1 and 1. Then the limit does not exist. This is what we mean by oscillating behavior. Example, use the graph of f to identify the value of c for which limit f of x when x approaches to c exists. To solve this equation, we will discuss the limit at when the function is not continuous, because when the function is continuous, already the limit exists. But for this function, I'll discuss here at 1 and at negative 3. At 1, when x approaches to 1 from left and from right, as you see, f of x approaches to 2, then the limit exists. But when x approaches to negative 3 from right, the limit is 2, and from left, the limit is 0. Then the function, the limit of this function exists everywhere except negative when x approaches to negative 3. True or false? If the function f is not defined at point x equals c, then the limit not exist. It is not true. It is false. Because if we want to give you an example, x power 2 minus 1 over x minus 1, this function not defined at 1. 1 minus 1, 0. This is f of x. Then f of 1 equals 0. 1 minus 1 over 1 minus 1 equals 0 over 0. Not defined. But the limit when x approaches to 1 for this function, it's equal to limit x analyze difference of 2 square for the numerator and reduce x negative minus 1 with x negative 1, substitute every x with 1, the answer is 2. So the function is not defined, but the limit exists. If f of c equal L, a number, then limit is also equal this number. This is also false, because if we have a function, a piecewise function, like x minus 2 when x not equal to 1, 6 when x equal to 1. Now, the limit when x approach to 1 for f of x equal to 1 minus 2 equal to negative 1. But f of 1 equal 6. The limit not equal to the value of the function. If limit f of x equal L, then f of c equal L also is false. The same example in 2, apply it for 3. Limit x approach to 0.25 equal to 0.5, it is true, because limit equal to square root 1 over 4 equal to 1 over square root 4 2 equal to 0.5. Limit square root x when x approach to 0, 0, square root 0 is 0, also is true. Example, word problem. Inscribe a rectangle of a base b and the height x, and an isosceles triangle of a base b in a circle of radius 1 as shown. This is the rectangle, and this is the rectangle, and this is a triangle, and this is the height of the rectangle is x, and the base of the triangle is b, and also the base of the rectangle is b. For what value of x do the rectangle and the triangle have the same area? Set the area of rectangle equal to the area of triangle. Area of rectangle is length times width. It is x times b equal to this distance is half of x. It is 1/2 x, or x over 2. This distance from the circumference to center is 1. Therefore, this distance is 1 minus x over 2. Now, the area of the triangle is 1/2 b times 1 minus x over 2 times the height of the triangle. Now, b with b, x equal to 1/2 minus 1/2 times x over 2, x over 4. Solve this equation to find the value of x. X plus x over 4 equal to 1/2. Equal, then 4x plus x equal to 1 over 2. Then 5x over 4 equal 1 over 2. Cross multiplication, 5x equal 10x equal 4. Then x equal 4 over 10 equal 2 over 5. Example, use the graph on the left, on the right, to answer to this, or to find the right choice. Limit number A, limit f of x when x approach to 1 is 4. This is 1. And the limit from the right is 4, from the left is 3. Then this statement is wrong. Limit f of x when x approach to 1 from right is 4. It's true. Limit f of x when x approach to 4 from left is 3. It is true. F of 1 is 3. Wrong. It is 4. Limit f of x when x approach to 3 from right. It is 3. True. Limit x approach to 1 from left. It is -1. Wrong. Limit f of x when x approach to 1 from left. This is left. X approach to 1. It is 3. It is wrong. D. Limit f of x when x approach to 3. It is 3. X approach to 3. From left and from right is 3. True. Limit f of x when x approach to 1 from right. It is 4. True. F of 0. It is 1. True. The right choice is D. See you next lesson.